Okay, so now you know how to, or I reminded you how to label the A value, the vertex, the H and the K value. So now we're going to get into a review of how to graph a quadratic function when it's in vertex form. Okay. Well, the easiest coordinate, just by looking at the function, is your vertex is these two numbers. And I want to remind you, I'm going to erase this. I want to remind you what the original form of a vertex function is. Okay. So you got the A value, the H value, and the K value, the X and the FX, the Y and the X coordinates. Okay. A is going to change the width of the graph, make it wider or narrow, and it'll also change it upside down if it's negative. And that's not something you really need to worry about, and I'm going to show you here in a second of why you don't really need to worry too much about the A value. Okay. And then the H value is always going to be the opposite, because minus is really saying opposite H. Okay. And then you got your K. So to get a positive 1, notice how the sign's changed. In order to change a sign, you must input a negative number. Okay. So the vertex can be -1, comma -4. Okay. And I'm going to teach this a little bit different than how I did it originally in class. Is we're going to take this coordinate and make a XY table. So we got X, and we got f of x. And this is much better. I'm going to change, this is how I'm going to do it from now on. Much better, because now we can confirm if this is in fact the vertex or not. Okay. So remember, the vertex is always your center. Okay. That's the center of the graph. And now what you want to do is pick coordinates to the left of the vertex and the right. So that's numbers that are lesser than -1. And we usually want to go 2 spaces. And then ones that are greater than -1. So notice how I have numbers in numerical order on the X coordinates, and it started with that middle coordinate. All right. Okay. And so now what we're going to do is we're going to rewrite our function, but instead of x, we're going to substitute in what we're trying to find when x is, let's say, -3 plus 1 squared minus 4. And this could be all done on the calculator. Okay. All right. And then when we want to substitute -2, that just changes that x value to -2. And same thing for 0. And same thing for 1. Okay. And now the calculator I'm going to use is a little bit fancier than what we're used to, because I left all of my calculators at school. So this is the calculator I have at home. So the way that I type it in is, it might not be the way you type it in. You may be using your phone, or you may be using a different type of calculator. But what I'm going to do is I'm just going to type all this in to the calculator and see what I get. So I'm going to put equal signs on all 4 of these coordinates. Okay. And with mine, it's a little bit easier because I can copy and paste. But what I'm going to do is I'm going to put parentheses. I'm doing -3 first, plus 1 squared minus 4. I'm just typing in the function, but instead of x, I'm inputting what the x coordinate is. Okay. Equals. All right. So I got 0 when I substituted in -3. All right. Now what I can do, what I like about this calculator, is I can copy and paste, and then just go change this -2 to -3 to -2, and then push enter. Okay, so I got -3 for that answer. Okay, and then I'm going to skip -1 because I don't need to find that. I already know what that is. Okay, but I'm going to delete this negative sign. I'm going to change this coordinate to a 0. So notice how I did 0 plus 1 squared minus 4 equals. We got -3 again. Okay. And then I'm going to copy and paste one more time and change that 0 to a 1. Okay, equals. I got 0. All right, so just want to talk just for a second about all these, what these mean. Okay, we confirmed that this is the vertex because we have repeating coordinates. That means we have mirror images. Okay, vertex or the quadratic functions will always have mirror images. All right, so we're going to have mirror images here. All right, and notice how we have mirror images on the outer coordinates as well. Okay, I also want to talk about when x is 0, that's your y-intercept. When y is 0, in these 2 places, those are your x-intercepts. Okay, so that's how you can see it from a table. And now let's graph these coordinates. Okay, so I'm going to just sketch my graph. Let's see. On the x-axis, I got to go all the way to -3. On the y-axis, I got to go down to -4. So really, you can just kind of offset your origin a little bit. Kind of something like that, because I only need to go to +1 on the x-axis, but I need to go down 4. Okay, so down 1, 2, 3, 4. That's the lowest I need to go because that's the vertex. Okay. And then on the x-axis, I'm going to go to the left, 1, 2, 3. That's negative 3 here. And then I'm going to go right 1 to get to positive 1. All right, that covers all of my coordinates. If you want to be neat and go ahead and take marks all over the place, that's fine. But these are the only ones I need. All right. So we're going to go negative 3, 0. 1, 2, 3, 0. All right, that's right on the x-axis. Negative 2, negative 3. It's there. And then negative 1, negative 4 is your vertex. Then I have 0, negative 3. And then I have 1, comma 0. So your graph is going to look like this. And I want to reiterate, make sure your graph is rounded here. Okay, it's not a V shape. It should never be a V shape. It should be rounded. Okay, it should be rounded here. All right. So we can clearly see x-intercepts. There's 2 of them. We can clearly see there's 1 y-intercept. And so now graphically, when it's on the x-axis, x-intercept. When it's on the y-axis, that's your y-intercept. So you know how to label it, or know how to identify that from the table, know how to identify that from the graph. And now before I do all this other stuff, I just want to remind you that if for any reason you cannot find these graphically or from a table, okay, well, just simply for x-intercepts, you're making y 0, which is going to be x plus 1 squared minus 4. And you're going to solve this for x. Okay, so we're not quite doing that yet. Okay, we will do that later in a later assignment, but right now, that's how you find the x-intercepts. And to find the y-intercepts, you want to find when x is 0. Okay, so this is solving. This is really just simplifying. Okay, so you simplify that. And I just want to reiterate, that's how you can find the x-intercepts anytime you want and find the y-intercept anytime you want. Okay, I'm going to erase that though because we can clearly see this graphically. All right, the x-intercepts were negative 3, 0 when y was 0 and 1, comma 0. All right, then when x was 0, we had negative 3 as your y-intercept. Okay, so in case you cannot see these graphically or from a table, just simply substitute in 0 for the y to find x-intercept, substitute in 0 for the x to find the y-intercept. Okay. All right, now domain and range. How I usually label it is by coordinate notation, negative infinity to infinity. The reason being is because this graph is going, it will keep getting wider. Okay, keep getting wider. So all of the x coordinates on the left, the negative direction, all of these are included because I can substitute in the x value and get an output. So that represents all the numbers going this way and all the numbers going that way. So that's why I will not stop going to the left, I will not stop going to the right. Okay. Now the range always has some kind of boundary. All right, it's going to be dealing with the y coordinates. So in this case, it's f of x. All right, f of x is the y. Now f of x is going to be either greater than the vertex or less than. So if you go down here, you look at this vertex. Is this the lowest or the highest point? Well, you can clearly see this is the lowest point. So that must mean that all other y values are bigger than that coordinate. Okay, so a symbol for bigger is greater than. But notice how there's a dot on this coordinate, so that's an or equal to as well. So greater than or equal to the y coordinate, which we saw from the vertex is negative 4. So notice how negative 4 is the last number. It is in the vertex as the y coordinate, and it's also in the range. Okay, so there's the pattern there. The axis of symmetry, we can always draw that. It is a vertical line that goes through the vertex. Okay, so we can always draw that. And notice how all these points are symmetrical. That's why it's called the axis of symmetry. Mirror images, aka symmetrical. Okay. All right, so axis of symmetry is a vertical line. Okay, so that's going to be an x equals equation. And what number does it pass through? Well, it's negative 1. So x equals negative 1 for the axis of symmetry. Okay, and notice how that is the x coordinate of the vertex. Axis of symmetry is part of your vertex. Okay. All right, max or min, what we talked about, this is the lowest point. Which one of these words means lowest? That's minimum. Okay, so that's a min. All right, and then the max or min of the function. Well, what is the minimum value that you get as the output? That's what we're trying to talk about here. Okay, so you can do this, you can draw a line if you want to. Where did you cross the y-axis right there? That's when y is equal to negative 4. You can look at your vertex of f of x. The f of x lowest point is negative 4. Okay, so this, I just want to remind you, it's not a coordinate. This is a value. What is the lowest output you can get, or the maximum if it's flipped upside down? Okay, all right, I'm going to pause I'm going to stop the video there. I'm going to give you one, maybe two more examples. So stay tuned.